It did, but they used to start now.
Gosh. Minor details. Yes. Okay, I'm serious.
I don't want to. I prefer not to ambush you with this point. So, this is the wrong one. So we got the 3x3 matrix here, but we said when we have the scalability column, it's a 3x4 matrix. And the column that's missing here, which is what I noticed, is this column, the accuracy column. And in the draft, there's a metric within the reported rate, the asynchronous message processing rate, but it also has the loss ratio measured at these rates. Yeah. And so what we've actually got here is instead of this table, which is a single table of results at each iteration of the test, and then an average at the bottom. What we've actually got here is a two-dimensional data, where you can plot the asynchronous message processing rate and the loss rate result. And I think we need to do that because all of the previous tools, like cbench and route cbench, and other things that are of the same ilk, they went on to report a maximum rate which was independent of the loss rate. So we're actually introducing this new dimension here, and it's incredibly important because for some reason people thought, and you know how this stuff works. You get a packet that you haven't seen before for floodings, and they send an academic to control. If that message doesn't get responded to, the flow is sitting there waiting, and that may time out, and eventually the switch sends a read request. But that takes another seconds. And from a user perspective, it's going to look like you don't have any activity. If you're operating the switch where the loss ratio is 10%, 20% operators,
Yeah, of course.
we got to be operating down at the sort of zero loss rate maximum. So I think it's important to report both so that we've got tractability with the old tools, but to take a stand that we want to be reporting the loss ratio that is zero loss rate. And maybe what's needed is sort of the loss ratio kind of is embedded in this definition.
No, see, go back. This is where this part was in the text. This was supposed to be the number of messages that PTA would not drop in, which means ostensibly the loss ratio is zero.
Right.
So I didn't notice that loss ratio in the beginning because I already had one out.
Okay.
If the objective is that you're going to do it without dropping, then I think by definition you can report loss rates. This is supposed to be that you're reporting a number where the loss ratio number effectively is zero.
And so I'm saying, in order to have a bridge to the way this used to be measured without taking loss ratio into account, we ought to be reporting both in the XY because people are going to measure this way. This is a lot lower than what I used to get with cbench or something. What's up with that? And if we've got the comparison between the maximum, like in RC 2889, the maximum frame rate, they have a maximum frame rate and a maximum frame rate at zero loss or something like that. So they actually report two levels of this. And I think that's the
So you're asking for a second rule on Tapla's test to have a second one where you're setting some number of packets and also recording the loss ratio.
It's the same procedure. You just have two metrics.
Well, yeah, one explicitly has an implicit zero, the other has an explicitly being recorded.
That's right.
Sure. I don't think that's going to be controversial. It probably solves the fighting arguments.
Yeah. The original definition didn't take into account loss ratio. And this is what I discovered as part of the sequel problem. Everybody's reported this value that it's actually meaningless because the loss ratio is, I finally saw some measurements and the loss ratio is about 10% or something at the maximum framework. So no good.
Yeah.
So let's fix this.
Okay.
And I think like I said, I think it involves also putting accuracy in here and having the
Loss ratio.
loss ratio be, actually the loss ratio applies next to this one. I send this message processing loss ratio.
Yep.
Okay.
Okay.
So that's a heads up. We can discuss it further. It's quite good to discuss it with you too. There's just a few more.
Okay. Thank you.
Good. Okay, I guess we can get going here. I hope that more people find us.
Okay.
So that's that. When somebody remote, I'm not quite sure. This is more and more people on the room. So let's just hold off for a couple minutes.
Before we get started, we wanted to let you know that the folks who sit at the back rows, you are automatic note takers and jabber scribes. And if you would like not to be, we suggest you move forward.
Although we do understand the constraint of power for your computer, so there's not a lot of jacks in front here.
I see an open power strip right in the front row.
Yeah, that's right. Actually, there's a whole bunch right underneath our AV advisor there.
And Warren's not known to bite.
Right.
Much, yes.
I'll start the blue sheet around. A spare piece of paper or something I can take notes on. If not, I will just rip off the back page of that other blue sheet there. Thank you. Use that. None of this is thanks. Hey, we're just going to wait another minute or so, and then. Take notes on
On the blue sheet.
On the blue sheet. This is good enough. I've already ripped it off.
I will go and find them, people.
Yeah, we'll steal a page from somebody
The next
else.
working group?
And they can steal one from the next working group.
Do you have anybody doing JavaScript?
No, not yet. Is anybody monitoring Jabber? It's still blocked for me. Otherwise, I would try. Yeah, the corporate. Yeah. Peter out here. Let's go. Good morning, everybody. This is, as you can see, this is the benchmarking methodology working group session. One of the first sessions here at IETF. We're your co-chairs. I'm Al Morton, and this is Sarah Banks to my right. And this is our working group meeting for IETF 99. If you're not subscribed to the mailing list and you'd like to do so, you can grab these slides and click that link and join us on the mailing list. How many people are attending BMWG for the first time? Quite a few, about 7 or 8. Very good. So welcome. You'll find that this is a really easy group to join if you have some testing background. And there's not that much literature that is absolutely necessary to be able to have read and to join our discussions. A few RFCs you'll see and hear as frequent references, and those are the ones that you kind of start out with to get a good background in this. And actually come and talk to either one of us afterward if you want a list of 3 or 4 things that are not bad to read to start. And we're in the process here of developing benchmarking methodologies, which is benchmark metrics and laboratory procedures for measuring the important performance characteristics of network devices. So welcome to our work. Let's see if the clicker works now. Okay. All right, so since this is the first session of IETF 99, it's important to go over this note well with a little more care. So essentially what we have is several documents here that describe the, is this going to turn me later? Yes, okay. So we have several documents here that describe the rules for IPR disclosure regarding contributions to the IETF. And contributions are oral statements or written or electronic communication made at any time or any place which are addressed to all of these bodies, i.e. IETF plenary, IESG, any IETF mailing list, any working group, which we are right now, any BOF, Birds of a Feather session, the IAB, the RC editor, and all the contributions are subject to RC 5378 and 3979, updated by 4878. So we basically ask that everyone be aware of these things. And when you registered for the meeting, you checked the box that said you were aware. and as a result, so we're expecting everyone to follow the rules documented there. And what does it mean? Essentially, if you have intellectual property or know of intellectual property associated with a statement that is a contribution, as I've just qualified it, then you need to disclose that IPR in a timely fashion. And that's all we ask. Okay. Everyone understand? I see a lot of nodding. That's good. And smiles even. That's good too. Excellent. All right. So on to the real work. So here's our agenda. I'll quickly ask for volunteers as a note taker. Volunteers? Okay. Marius, thank you. And anybody else? We usually try to get two. So that while one note taker is speaking, another can help out. Anybody else want to volunteer? All right. Well, we'll hope to get some help with that. And in fact, feel free to join the Etherpad, the details of which I can't easily provide you because my PC is locked up here, but we can get that going. So here's our plan. We still don't have a Jabber scribe, right? Oh, okay. Sarah's going to take care of jabbering. We've talked about IPR. The blue sheets are circulating. And Takey, I noticed you need to sign the blue sheet, please. So it's right up front here. Just and try to keep the sheet in the back. And if anybody walks in the door, hand it to them and suggest that they do as all the rest of us have done and sign it. And that would be great. All right. So here's our agenda. We're first going to talk about the working group drafts and the status of the working group. Briefly talk about our charter and milestones, and then we'll go into the working group drafts, of which right now, as I'll mention, only 2 are left on our charter. So that's a good thing. But it leads us to a recharting discussion, which I put on the diagram here. Yes, okay, it is there. I forgot to reorder these in the online agenda, so that's okay. I'll fix that later. All right, good. I was sort of thinking about that, but I didn't realize I did it on the slide. Good. So then we have a draft which is sort of on its way to working group adoption. I think that's the best way to describe it. We had good support at the last meeting for adopting it. We had many people say on the mailing list that they would support it, but only a few said that they would actually review the document when I reminded people that that's a part of supporting the document. Writing one word in an email reply, support, that doesn't get it over the edge. We really need, the truth is, we need expertise in these areas to be able to complete the work in a manner that's going to be useful to the industry. So that's the kind of thing we're looking for to be demonstrated in the review comments and so forth. When you say that you support a draft and you reviewed it and you have this question about it, that's how you demonstrate that expertise. So we've got that draft and it is moving forward toward adoption. I guess that's the best way to put it. Now, then we've got several other drafts which have been proposed. One on service function chaining. Keiki Kim is here to present that. And then we had this other one, considerations for benchmarking network virtualization platforms in the data center environment. And that's unfortunately going to be wiped off the agenda today. The presenters weren't able to join us, and there hasn't been an update on the draft either. But we did have an excellent discussion of this in Chicago, so I was hoping that they would come through and join us. So then after the drafts that we discussed today, we'll have a rechartering discussion. And we'll kind of put down our ideas and get some feedback from the group, and then discuss a schedule for rechartering, because we have very nearly completed all of our chartered work items, and that's a good thing. The question is, do we have enough work to continue? And I mean, personally, I think the answer is yes. So then the final thing we'll do today, and this is the kind of thing that we've been able to do a little bit when we have a long session like this, is to take a look at some related presentations and topics from other organizations. For example, last summer we heard from a software-based traffic generator design team, the MoonGen traffic generator. They were here with the Advanced Network Research Workshop last year, and then stayed on to give our group a good talk about this MoonGen traffic generator. And then we also heard from the FDIO continuous integration and testing team, and the kind of work that they were doing to test the Cisco, now the FDIO open source VPP virtual switch. So this year, what we're going to hear is a talk about the OPNFV VSPerf, that's the vSwitch Performance Project in the open platform for NFV. We'll hear about benchmarking results, test results actually from that project. We've heard about the project here many times because that group made contributions to our work in the area of sort of test setups and configuration parameters for repeatability. And now we're going to hear a bit about what they've done with recent testing and the results that they've collected. And there are, of course, implications on our future work, and I'll try to emphasize that as I go through it. So as you can see, I have my OPNFV Summit T-shirt on today, and so in that particular talk, I'll be representing our project work with my two co-authors. And then we'll have any other business at the end. So any questions about the agenda? Any bashing to take place? Seems not. Okay, so let's move ahead then. All right. So here's the quick working group status, and this is why we're rechartering. We've got IESG approval on the VSPerf, that's the OPNFV project I just mentioned, the vSwitch draft. So we've got that just accomplished a few weeks ago. We also got IESG approval on the IPv6 transition technologies draft. And they were actually going through the IESG the same week, which made it very interesting. lots of traffic on our list. And then most recently, we've gotten IESG approval of the data center benchmarking drafts, which were working here for quite a while. And that caused a lot of commentary and additional feedback. So, and now the working group is really seeing all this feedback. It's really quite extensive, and it informs us in ways that we need to know in order to get our drafts through more efficiently. So it's good to read the kind of feedback we get from the IESG members in this final stage of approval. And as I pointed out, the talk, both the major talks we have today are new work proposals. They keep coming, and I'm sure we'll see some more. So additionally, we have two new RFCs that were announced in the interim period. We have RFC 8161 on IPv6 neighbor discovery. I'm sorry, that's what ND stands for there. I should have probably spelled that out. But we have a draft on benchmarking that, and the very next one that's going to be announced probably sometime today, I would guess, or this week at least, is 8172 on the VNF virtual network function and NFV network function virtualization infrastructure benchmarking considerations. This was the first step in our working group charter pivot to begin to take on the benchmarking of virtualized network functions, and which was a key step in our rechartering activity the last time around. We've previously done a benchmarking of physical network devices with their dedicated hardware, but now we're expanding our focus into this virtual network function and their infrastructure benchmarking. So this was first step, and glad to get that complete. If you're beginning to work in this area, this is an excellent draft, I think, to take a look at. There's a lot of good working group considerations and contributions there to consider as we begin this topic together. So we'll have a discussion of rechartering. That's our charter update discussion. And very soon, we'll have our supplemental BMWG page announced. Sarah's been working on that and has created the place where we'll sort of keep our interesting information about, for people who haven't been able to attend a meeting, the kinds of things that I said when we got going here, how easy it is to join the group and what you need to do first and second and third, things of that nature. And in the past, we've included reviews of particular documents there and analysis of comparisons and so forth. So it's been useful to have our own supplemental page. And unfortunately, Comcast decided that they no longer provided web pages for residential customers. So that's why the old web page is gone, and we're going to get a new site for the web page of the future. So that's that was kind of a surprise. They do it for small business customers, but oh well, not me. So here's the quick status on the milestones, and yeah, so we've only got one left. Isn't that cool? And it's actually, it's intended for this month, and well, we'll certainly have that, and we'll work on the various comments that we just talked about together. But we're really close to completing everything that was on our charter, and that's why we're going to have this rechartering discussion. So I think I will hold up the presentation there and ask if there's any questions about the status of the working group or our current work. No? Good. Okay. So so yeah, this is it's been a very successful last year or so in getting all of these drafts move forward, and that helps us to make space on our attention span and our working group agendas to be able to adopt some new work now. And that's why we're beginning to consider these things in earnest. So let me bring up the agenda here. This is okay. So I think our first item on the agenda is to talk about our last working group item, a set of two drafts that constitute benchmarking methodology for SDN controller performance. And we've been working this for a while. Sarah is one of the co-authors on this work, and so I'll turn it over to you, Sarah, to give us the stats, please.
So with feedback from Al, the last time this went out for working group last call, there were some comments that came in. Those were addressed. When we uploaded the draft, Al caught something that maybe I should have, which was, hey, it's not clean. When I do reviews for Ops Directorate, I'm usually the first one to pick out on nits. So I found it very ironic that
it's an easy step to skip.
That Al was like, your nits are totally dirty, and they really were. I think there were like 14 or 15 issues there. So in any event, we've gone back through and cleaned up those nits. That was, I believe, submitted 2 weeks ago now, so it was under the deadline. And so at this point, I think we're looking or asking the working group to do another working group last call.
Very good.
It's been a long time coming. This draft has been thoroughly reviewed and worked on for quite some time. So if you're new, you might be wondering, wait, what? It's going to working group last call, but it's been around for some time. It's gone through a working group last call, and we're kind of at the end of that process now. It's kind of how I feel about it.
Sure. So first off, any comments from the attendees about this SDN controller benchmarking work? Okay. Well, so as I mentioned to Sarah before, I have a couple of comments, and one of those is related to one of the drafts that we've just got approved and basically all the way through the publication process. And that is the considerations for benchmarking BNFs and related infrastructure. This will be the RFC 8172 as soon as the editors announce it. Everyone's now satisfied with what we've got there, including the editors. So when I was looking at this particular section in that draft, I was looking at let's see, where did I set this? Well, I won't try to find that now, but there are actually two drafts in the working group which have sort of embraced this matrix for organizing and evaluating the benchmark metric coverage that's provided in the draft. And the way this matrix works is this. We have these different phases of communication listed in the first column. It's activation, operation, and deactivation. So you can kind of think of like setting up a path, evaluating the performance of that path in terms of its throughput, the transmission rate, latency, loss ratio, and reliability aspects of that path. So we're going to activate the path, and how long does it take? Does it get activated accurately? Is the activation reliable when it's repeated multiple times? So these are the kinds of things and areas that we could be benchmarking, and it's important that usually important that almost all of the cells of this matrix are covered by benchmarks or performance metrics. And what we learned in the process of applying this to benchmarking is that in fact we needed an additional column here, one that measures the scalability of the size of the devices and the network functions that we're benchmarking. So how many sessions can a device support, and how many switches can a controller control? These are scalability aspects that needed to be represented in the matrix in a way that we didn't have to worry about before. So when it comes to evaluating coverage, what we actually have is as I mentioned somewhere here, is a 3x4 matrix where we have scalability out here as the additional column. But this was the matrix that comes from an ANSI standard, ANSI X3.102, and it was originally designed for data communications evaluation back in a long time ago, back in the 80s. But it's been very effective to apply it to our work here, and we've done that now in two drafts: the SDN controller draft, and also in the VS perf contributions from OPNFV into our work here. We evaluated all the different tests that the VS perf project has designed. So in making sure that these citations were correct, I looked into the the controller performance draft, and this is one of Sarah's drafts that she's just discussed here. And in fact, what I noticed was that the accuracy column was missing. And I originally thought that was just a synchronization issue between, this is the terminology draft where the benchmarks and other terms are carefully defined, and then the draft on methodology, and that's what this one is. So here's the section in Sarah and her author team's draft on controller asynchronous message processing rate. So imagine a case here now where you have many switches connected to a controller, and they all have an association with the controller where the controller is going to accept their request to establish a flow, and then to give back the information necessary to insert in their flow table to be able to accommodate that flow in the future on a switch-by-switch basis. So as a flow enters the network that's controlled by the controller, it's going to see many of these packet-in messages, and it's important to know for a given number of switches how many of these flow requests or packet-in the open flow parlance can they accommodate. But one of the things we learned in the process of this is that many of the original controller benchmarking tools didn't pay attention to packet-in, which is like a flow update request, message loss ratio. If a request came in and it was dropped or not honored, then a flow would be sitting there wanting to continue to send packets, but no way to do it. And that's really bad for network operators. But yet that somehow was overlooked. So so we've added that aspect to our definitions, and it's kind of like if you have a background in this work, it's kind of like the zero loss ratio throughput level, which we characterize in RFC 2544. But then in the full mesh LAN switch characterization, RFC 2889, we have a maximum flow rate there, which is independent of the loss. So there's really two kinds of parameters here, and the point was to try to capture both of them here. The old benchmarking tools have typically characterized the maximum message processing rate, but what we'd like to add, and we've begun to do that based on comments here, is to characterize the rate where there's no message dropping, so a zero loss ratio, and that's always going to be less than the maximum with frame dropping. There could be as much as 10% or 20% frame packet-in request drop rate at these maximum rates, and that's really unsustainable in an active network. You can't have 20% of your flows just sitting there unserved. That would be horrible. So we want to make that distinction, but we want to have the maximum so that there's kind of a correlation with what the old tools used to measure, and now we can clearly indicate the value of this new metric. So basically I'm suggesting that we go back and add the accuracy column here, and then pick up what would be this measured loss ratio, and kind of plot that in a two-dimensional form, so that you'd have the offered rates and the loss ratios and the achieved asynchronous message rate that the controller can provide. So that's the feedback that I've given today, based on sort of the comparison of a draft that we were just finishing up with the RFC editor and this one. And I'm sorry that it's taken a bit long to get that all in one place here, Sarah, and to your other authors. But I think it's good feedback. So thanks for accepting it. So that's the kind of interactions we have here. Right now, I'm sorry, it's only been between the two of us. And I'm hoping that more people will be more engaged when we get more detailed presentations of some of the further drafts as we go along here today. But obviously, feel free to come to the microphone, and when you come to the mic, please say your name first. That way we've got a good identification. I mean, that's one of our rules here. I think there's a sign on the microphone that reminds you.
Yeah, it's pretty clear. Okay, this is Marius. I just wanted to say that, I think the authors took into account my feedback, and I'm satisfied with that. So, well done for that. That's just that. Thank you.
That's great. Thanks very much. So we'll start the working group last call shortly after this meeting.
Yeah, why don't we?
And we'll include this.
I would like to. That way it's ready to go when it goes in the working group last call. It's clean. as clean as it can be going in. How about that?
Oh, you'd prefer to make the changes and then do the working group last call?
Yeah, I think they're really good changes. I don't think the other authors are going to have an issue with this. So I think it's minor to add it, but especially if we have new folks reviewing, I think it's a lot cleaner to go
Okay.
in with a clean draft.
Yeah, fine.
It'll only take a day or two, and we'll upload.
Okay. Okay. And since we're in the same location, if you want to be sure that we've fully understood each other this time, let's talk about it if we can.
Thank you.
Good. All right. Great. Okay, so we'll have a working group last call after the next revision of this draft. That's the way we'll capture that. Very good. Okay. By the way, was all this text up here fairly visible to folks? Big enough to see? Okay. All right. I see some people in the back of the room nodding. That's mostly what I wanted. Thank you. Sorry for the eye test if not. Okay. Oh yeah. So my agenda is here. I think still. All right. So our next item is this draft on benchmarking methodology for Ethernet VPNs and provider backbone eVPNs. Sudhin Jacob is here from Juniper, and we have a related draft here that's gone through many iterations. Sudhin, I invite you to come up and make your presentation of the latest work here.
I mailed you the PPT.
Pardon?
I mailed you the presentation. Right?
Oh yeah, I've got it. Yeah, you don't need your laptop. I'll bring it up here.
Oh, perfect.
Yeah. Yeah, he can have the clicker then. Yeah. Let's see how this is going to work. Good. Well, the price is going up. It used to be a beer.
Oh, yes, yeah.
Price of a beer.
Yeah, hi. Yeah, good morning, everyone. This is benchmarking on EVPN and PBB EVPN. This is the new RFC which came year and a half back. So this was is a new RFC 7623. So this is it's now it's widely deployed in the provider arena. And the main feature of this EVPN is like you can have both routers in the forwarding compared to VPLS, because you have to run either spanning tree or work as active and standby. Here, both links can be utilized. So what all the money you pay it, that you will get the maximum benefit. That's the main main features. Like compared to VPLS, the EVPN became a big hit and people are deploying it with various flavors of EVPN. So which I explained. Yeah, the comments, it was from the last IETF, it was they want type 5 routes, because type 5 route was not a part of RFC, which came as a separate draft, because there are a lot of drafts which is going in best working group, it's like a vanilla feature. EVPN and PBB EVPN is like a 2 RFC's vanilla features. They add a lot of other things like, say, for example, they want to run VPWS over EVPN, E3, ELAN, kind of different services. So they spin off a new draft. So actually, this was type 5 route itself is a draft which is adopted by the IETF best working group. So they want that also to be benchmarked as part of EVPN when we benchmark EVPN. So they ask, okay, why can't you do that? So I incorporated that as one of the parameters because we have defined the parameters. So now the problem is EVPN is implemented by different providers, and it is very difficult when you the test community, as well as when you buy this product or the services rendered by different vendors. So you have to have apples to apple comparison. So you don't know, okay, say vendor X or service provider X is giving this. So how I rate it, there should be some standard, there should be some yardstick or parameters have to be measured. So that's how the motivation behind this draft. And type 5 route was the ask in last IETF, so we incorporate that as one of the parameters. So this is the test setup, because the DUT is one of the multi-home PE. This is a typical EVPN deployed scenario. So because it will be active, because that is the most deployed scenarios, where active, because that is where both routers will be forwarding the traffic. Unlike in VPLS, one will be active and one will be standby. So the load balancing will not happen from the remote routers in VPLS. But here, that is one of the aliasing is one of the key feature which we can say. Yeah.
Sorry, one quick comment.
Please.
Where is the receiver in that diagram?
Yes,
There's no receiver.
I was wondering the same thing. And Marius, don't forget to say your name, Marius.
Yeah, sorry, Marius. This is Marius.
This is the traffic generator. We will be sending the traffic, and
there's two senders. Like, which machine is
the
receiving?
customer edge device is where.
So the measurements are well reported by one of the machines under test.
Yeah. The performance will be measured, because in this network DUT will be put there, and in this DUT we are running the sort of test, and the reports we will be getting it.
Well,
so that will be treated as a black box.
So to be clear, you're saying there's only one device under test, and it is the DUT that he's noting, and not the CE or R1 that you have at the top of the diagram, Sudin? Is that what you're saying?
The DUT is where we have to have in test scenario, we have to have a DUT wherein you run the test and you measure the parameters. But to place the DUT, you need to have other elements, network elements there, and the traffic which is pumping, bidirectional traffic or unidirectional traffic which is pumping. That's why we written 2 RT ports, or the router tester like Ixia or Spirent will be there. So the DUT is where is a reference point. The benchmarking reference or the viewfinder will be pointing towards the DUT.
Okay, I think that should be clarified. It's not very obvious from the draft that that's the case.
It's mentioned there in that test setup. Clearly mentioned that the reference point which is mentioned, and the traffic is pumped from unidirectional or bidirectional. The traffic is sent, and the frame rate, all the details have clearly. I think someone raised 2 IETF back, so we have added all those points, the frame rate and all those things which have clearly mentioned. This layer 2 frames we are doing it.
So I've looked at the procedure as well. It's not clear to me. I'm just saying it's not
clear.
Sure. What do you do with that feedback? That's your.
Sure. I'll add it.
I understand that for you it's clear. I'm just saying that for me it's not.
Okay. No, actually that's what in that section test setup it was mentioned there. I mean, is that the reference? So in that the question came, so we added explicitly, this is where it is like that, we added that. If that is not clarified, we will once again look into it, and we'll definitely look into it, because that is where test setup in that this explanation is given, and all that.
Yeah, because usually the devices or the device under test or part of maybe it should be, I don't know, put the frame, like one of the solutions I can think of, just like a frame around anything that's anything aside the DUT should be, a box that says tester, and then explain that the tester is a multitude of machines like router 1, RRP, CE, and MPHP. So that's how I would kind of try to take care of it, because otherwise it's really confusing. You have 2 sender, like two traffic generators, and RFC 2544, which is like
that's about RFC 25. It's a frame which is sending the same methodology we incorporated.
Yeah, but I'm just saying that the clarity in that in that test setup should kind of be similar to what you're describing here. It should be clear what the tester is, what's the device under test. That's my it's like kind of an overview comment.
So to add to that, I think, Sudin, a couple of things. Having your R1 and your CE1/tester, right? I think a lot of us, when we see multiple routers on a diagram, I think we instinctively think those are all being tested. And
sorry.
And I see your point, it's not, but I also see Marius's point, and I think we talked a little bit about that yesterday. Reading back through the draft with your test hat on, with fresh eyes, and I realize that can be a little
Yep.
harder when you're the author, but reading back through and say, okay, if I
understand.
was going to go sit down and test this, does this make sense? And I suspect you'll get a little more appreciation for what Marius is saying.
Yes.
I find it a
so
little confusing
you
too.
the clarity. I mean, you want to have a clear demarcation, like
Yeah,
what you-
exactly.
definitely,
That's the point.
that's a point. It's noted. So if that setup, test setup, and the duty details, we will make it more explicit with bullet points in that.
Okay, thank you.
Thanks, Marius. We'll definitely appreciate your points. Can I? I think so. I can move to the next, right? Yeah. Thank you. So these are the parameters which we defined it. These are the parameters like for the EVPN, the basic EVPN. The RFC is for like the MAC learning, MAC flush, MAC aging, high availability. Then ARP and ND scaling, because there's a MAC plus IP concept in that RFC 7623, the EVPN. Then the latest addition, that's a type 5 route scale, the scale, convergence, and the usual testers like we do is a soak test. So it's the MAC learning. What we do is like there are different types. The local learning, remote learning, and that is when the MAC is sent from one direction, then that is a local learning. Then the MAC is coming from the remote router. The time take to learn the certain amount of MACs, that, and when you are sending the bidirection traffic, and what is the amount of time, and this is repeated in interval, and it is plotted, because these MACs are advertised by BGP. It's unlike VPLS, it's a data plane learning, but here is the MAC details is advertised to other routers as a type 2 route, because they have defined certain NLRIs in EVPN.
So, Sabine,
Yeah, please.
so on this diagram, you've got learn local and advertise to remote peer.
Yeah.
On your test diagram, can you show me how the packets would flow?
Yeah.
For those two cases?
Yeah, the packet is the local traffic will be the CE. It is like a bridge actually. That will be a bridge.
That'll be a bridge.
Yeah, that will be a bridge. Oops, yeah, sure.
I think it's like very complex.
The red one, yeah.
Wow, thank you. Yeah, actually, this will be a Lego bridge. The traffic, the local learning is the traffic which is bridged from here and reaching here, the DUT. Because it's a multi-home scenario, the traffic will be reaching here. So the traffic will be reaching here. The time taken to learn the local MACs and the time taken to advertise to this remote router. Because the local learning, it will be in the CAM table or the local MAC table. From there, it has to give to the BGP, and BGP has to advertise. That depends on how fast the BGP update goes and all. So that is where the delta comes into picture. The learning and the advertising rate will be different. You learn in the MAC table, which we follow the previous RFC, which explained about how the MAC has to be learned, that methodology we use. And the advertisement is from how frequent from the BGP advertisement, how long it will take to advertise that n number of MACs or x number of MACs to R1. So I hope.
So that's good for local. Give me the next one, the remote.
Yeah. Remote is from that traffic is sent directly to R1 because it's connected directly to R1. So the R1 it will be learn the MAC and advertised to here. So the same thing, reverse path will be applicable here. The local the MACs in R1 will be advertised as a BGP. So it will be coming as a BGP advertisement here. Then if from the EVPN database, it will be populating to the local path.
Okay.
So there is the R1 has to advertise. There is time differences there. Then the BGP advertisement comes here. Then from the from the BGP advertisement to program the actual table. So that's where the
So then the fundamental answer to the question, which I think Marius was raising, is that really all we need to do in order to accomplish MAC learning is to generate packets with MACs that need to be learned. And then to measure the benchmarks, we're going to be looking at the control plane interactions between the devices in your setup in order to determine when a MAC's been learned and when it's been advertised in BGP. Is that correct?
Yeah, that's the same we are doing it because
All right.
the BGP itself, it has serialization delay. Then the NLRI, the pack, as per the RFC, it has to hook up and send it. So that is where the actual benchmarking has to come. How fast the device, like various vendors' device, how it has to work. So
Great.
that's where, as a tester, this is one of the parameter which.
Very good.
Yes, sir. Please.
Jimmy Tower, AT&T. To echo what Al said, I was a little confused. So the benchmarking is from the DUT to R1 bidirectional advertisement of the Type 2 route MAC/IP.
This test is first I'm discussing about the MAC. So the DUT is the reference point. So I'm keeping the DUT as a reference point, Jim. So you have the local learning, which is there, and the remote routes, which is coming from the R1. I have to populate to my MAC table because that is coming as a Type 2 route. Because R1 will be advertising to the DUT as a Type 2 route. Then I have to receive that routes. Then I have to put it in the MAC table. So how fast I have, say, for example, NMAX, how fast it is receiving
So
that?
I guess, Mike, where I'm confused is I'm going the other way. CE1 generates traffic to DUT. DUT sends a Type 2 advertisement to R1.
Correct.
Okay. So what I was sort of saying was the benchmark you're doing here is between DUT and R1 and MHPE2, because those are where that's your control plane.
Yep, control
setup,
plane. Yes.
right?
Yep.
Okay.
That's a control plane which is going.
So one other comment about this, in a multi-homing active-active environment, you may never get a MAC advertisement from MHPE2, just the ESI advertisement that is equal to the one on the DUT.
Yep.
So when you benchmark and say how quick, this is where if you remove the ESI from MHPE2, you invalidate all the MACs at R1 that have been learned from DUT. So it's not, it's possible you won't get the MAC advertisement, the Type 2 from both.
Yep. If it is, yeah, you are correct. Because this is also advertising for the local MAC. There is one way we can do is like make it a single active. So all the MACs will come to here.
Right. I was saying, so yeah, in an active backup scenario, that would be.
So all the MACs, say N MACs,
right.
say, correct.
But in that way, it's quick. That's where we made it fast. We made it fast, just sending
to
the ESI, the ESI advertisement saying invalidate everything that's associated with the CSI.
So if it's active cycle, so this will be the active. So
right.
All the MACs will be going here.
Right.
In active, I agree with you because this is also will advertise because load balancing will happen. This will advertise as a Type 2 over here. That is also a delta is there. But local MAC, the what we define is this will be the standby. If you make it, then you can run all the MACs here.
Absolutely.
That is all the MACs, N MACs, because otherwise it will load balance. It will be the measuring won't be accurate.
Right. All I was saying was that when you measure, what you're measuring is the advertisement of the withdrawal of the ESI and the invalidation of all the MACs, such that you now center them on MHPE2 in an active backup scenario.
That ESI withdrawal, we are not benchmark it. It's a learning in the learning rate. That's that you can as a one of the trigger benchmarking. We had there's a learning rate. Bringing back the ESI, so withdrawal Type 4 withdrawal comes and that is not not there because this is a learning. It's a vanilla test, so it's not a trigger. So that is not added. ESI withdrawal is not added.
So ESI withdrawal is an optimization to make it much faster than you would if you had to invalidate every MAC upon learning of the MAC withdrawal.
So if Type 4 withdrawal immediately, then the Type 1 or to the remote, this one, we'll look into it.
So Sudhim, what I'm hearing is carrier feedback that maybe you should consider the withdrawal scenario, and I think you should also explicitly consider active-active and non-active-active in both scenarios, because I hear you, this is about learning, but there is no learning without withdrawal. At the end of the day anyways, I agree that learning might be its own discrete test, but I think having a withdrawal is also very important to measure. There's never been we all do it anyways when we're out testing for as vendors, we all do it for our customers. They're asking us for it anyways. So to have the draft without that, in my opinion, it's lacking. So I really hope you would consider adding both scenarios.
I mean, just from a carrier perspective, So
Yeah,
when
Jim,
a new customer comes on, you learn something, they're not unhappy because they're just coming on.
Exactly.
Okay.
Now, when something goes down and they're out for a certain amount of time, then they're unhappy.
Exactly.
So we have to, so you should look, when you benchmark it, you should add that, that should be the primary thing.
That is, Jim, actually, we added that as a link because normally in provider, the link failures is frequent. So we added that link failure, local and remote, which is added that for benchmarking because ESI withdrawal, because what we have done is a link, that's what we have added as a parameter is like a link, the failure. That is where the MAC flush is a parameter. Next time coming to that. The local failure, that means is as good as ESI failure. The local as well as remote. So how fast is it is getting flushed? So that is covered actually. That's called MAC flush. That is the link failure. We are simulating it. That I can come to it as, yeah. 1 second. Yeah, the flush, MAC flush. It's what you are referring to it.
Now I hear, so if you just go back to the picture a second, I guess as an operator, this is what I sort of want to know. If I had an active backup scenario where I was using DUT as my active, to send traffic to R1 and R1 to DUT and MHPE2 as my backup. And then I crush DUT. How fast does it take for my service to come up? That's sort of really what I know is, and then encapsulate like, then characterize in that manner. How long does the withdrawal take? How long does blah, blah, blah take?
Yeah, Jim, this link failure is there, but how fast the other one MHPE2, so if you break it here or the DUT, that is not covered. Like the flush and the remote link failure is covered. Like how fast one of the MHP segment is failed. So in the recovery rate.
Yeah, so things like how long does it take the MHP to become a DF, right? DF election has to take place. And so all these things have to take place when you cut that flame from CPU1 to DUT.
Because that is covered in MAC flush. The link failure scenario which happens in the provider is covered. Like the ESI cutting off, that is indirectly, which is, link cutting is indirectly, which is referring to the ESI cutoff. So the MAC flush, the two scenarios are covered. One is the local failure, which is frequent in the provider environment in the metro ring. So, and the remote failure, which is in the remote failure, how fast is flushing the routes? Because the type 2 withdrawal is the important. Otherwise, traffic will be blackhauling. The customers will be affected. So that is taken.
So, Sudin,
Yeah.
I think you're covering, from what I recall reading, you're covering MAC flush on the DUT. That's explicitly, I think, not what Jimmy's saying. And I think, again, we can take it to the list. We can talk about it afterwards because I think we're starting to rat hole a little here. But this is all, again, this is all from the perspective of the DUT. That's not what he's saying, right? For the other PE to become and go through the DF election and stuff. I think that's a conversation that maybe we should have after if you're open to hanging around for a little bit and we can talk about how to potentially add that in. Okay. But I do think it's to put out the draft as an RFC without that in there, I think is something I'd like to hopefully convince you to consider.
Okay. DF failure, okay, fine. I'll get back. Give me, let me complete. I'll get back to you.
Okay.
Just give me a second. So now the MAC aging, MAC learning, we covered it. MAC aging is, it's a normal aging scenario. We are referring to it. So we scale to N max, like we are not N. We are, as a tester, it is up to, the tester to reference the point as N. So scale to N and stop the traffic. So how long it will take to flush off that N number of MACs from the table, and as well as the remote. You learn as a type 2 from the remote. So the remote traffic is stopped. So it has to age out from the remote router and it has to send the type 2 withdrawal. So the type 2 withdrawal comes, it has to flush, it has to signal the local MAC table and remove all the MACs from that table. So because that is where one important parameter, because if the withdrawal didn't come, if the withdrawal there is a problem. So the issue is like even though the traffic is stopped, the MAC it remains there and the blackhauling will be there. So that is one scenario we covered it. And MAC flush, which already we discussed, like the local failure, that's simulating the failure in service provider, the local fiber cut in the local as well as in the remote.
Steve Tower, AT&T again. So these are all great things, and I think they're valuable, but I question whether or not, sort of like Mac aging, whether or not the timeout comes from a withdrawal update or locally is really as much a function of EVPN as it is of the local implementation of reprogramming those boxes once you age out. Right.
Yeah,
So I would just say that, because again, back to the optimization, like the ESI optimization, if a whole bunch of Macs time out associated with a certain Ethernet segment, you're not going to get individual withdrawals for that. You're going to get the withdrawal for the ESI, and then you're going to invalidate everything and tell your Mac table, hey, invalidate these Macs at this point.
Okay, thank you. So this is ARP and ND scaling, which in the Mac plus IP routes, because the EVPN in compared to VPLS, it has a feature like when an ARP is sent to a gateway, it will learn that Mac as well as that's a my Mac concept is there. So it will advertise the Mac and IP to the remote routers, so that the inter-VLAN routing, so unnecessary ARP flooding and all, it is avoided, which is not there in the conventional VPLS. So in data center, VM mobility and a lot of other features are dependent on this. So it depends on the box how you can, how many, because it depends Mac plus IP, that NLRI payload. So how many routes it can scale. It has Mac plus IP, and the NLRI explains about Mac plus IP and IPv6. So what is the scale? How many it can scale. So that's one parameter we add.
Sudin, before you keep going, can I ask for next meeting when you bring these slides back in with updates, presuming you're going to present next in Singapore, could you put the diagram that you had originally, could you put that in on the side and then highlight what's where?
Yeah.
Oh, okay.
Because a lot of times you're saying the sender, and while I think I can guess what the sender is, it'd be nice. I think that's part of the problem to Marius's first point. We're not entirely sure when you say the sender, because you have two sources that are bidirectionally sending, where. So if you could just tuck it in and then just highlight.
Yeah, center. So you mean.
Thank you.
1 second, Sarah. Let me.
You don't have to go back now. I realize that you need to do it next time.
You mean to say here, right? A small turbo.
For each one of these slides that you've been going through, where you're talking about learning and flushing, and could you put down and then specifically call out where and what? Okay. Because I think through the questions that Jimmy's asking, you're doing it with a highlighter on the screen here, but unfortunately for the Meet Echo folks, it's not carrying through.
Oh, okay.
Well, it's even more than that. This is the kind of detail that needs to appear in the draft,
Yeah.
so that the actual measurement and benchmark are understandable, and executable, of course, and if you can reference documents from the RFC that you're referring to, if there's figures there that will help, then that may be sort of place in starting to be able to incorporate these figures so that everyone can understand these test setups. I think we all sort of understand the concepts here, certainly, but the unique details of EVPN are not my expertise. Obviously, it's Jim's expertise and your expertise, and those are both coming out in this discussion. So now we need to make sure that that's incorporated in the draft as well.
You mean where it is the reference point? It has to be, because as a generalized, we have covered that in scale, and Marius, I noted that point. So there's a little more illustrations on that. It will be done.
Right, but Sudin, I'll point out there's a lot of pushback to the feedback you're getting. But if you're getting the feedback, it tells you, I think, that the way you're describing things here and the way it's reading in the draft isn't, I don't think, coming across as crisply and cleanly as you expected it is. And if we're struggling with it, then other folks who read the RFC would struggle with it too. So, let's circle back to this based on the discussion we had yesterday. But
yeah, fine tuning. Let's the things things has to be as Maria said, it has to be fine tuned. We'll do that. Okay. Fine tuning. It is Sarah. It is done, because maybe certain things Jim also told the fine tuning will be done. That is, and when the presentation, like giving a small topo details and the sender receiver, that also we will have.
Okay, so not to nitpick, but I think it's a little more than just fine tuning. I think a good chunk of the methodology, why you're doing the test, what's what and what's where, that is missing from the test cases. So I think it's a little more than just fine tuning. I think there's a good amount of surgery, gently put, that needs to happen on some of the test cases in the document to make them readable and repeatable in such a way that if I were to do the test and Al were to do the test, we would both be executing in the exact same way,
Okay.
which is what BMWG is in a lab is about, right?
There's basically important background details missing.
Yep, the background details,
For
because
those of us who aren't EVPN experts.
no, the thing is, it was written in with respect to, okay, they with an environment where the people familiar with it. Okay, I'll explain so that anybody can take it up in that respect, definitely.
Okay, so I'll also point out, I don't know that I'm as familiar as Jimmy is, but this is not my first rodeo with EVPN, and I still was a little unclear as to where you were going with a good amount of the test cases. Sometimes it's just not clear, and I'm making assumptions, and sometimes when you're talking in here, they turn out to be the right assumptions, but I shouldn't have to assume. The document should be very clear and straightforward as to what you should be doing.
Yep. What I explained is, it's clearly each test cases, it's mentioned there, and the details, but the test setup methodologies, I know we will definitely relook into it, and we will explain in such a way that so it is like if not familiar, a person which is not familiar with the EVPN can understand that. We'll definitely look into it. That's what the point, right? We'll test cases are
I don't think it's about people who are unfamiliar. I think even for folks who are familiar, there's still a chasm that needs to be bridged. It's not clear and crisp to me at all on a good amount of the document so far. So this is what we were talking about yesterday, taking the draft from where it's at and having it become a little more stable, for lack of a better term, before we send it over to folks in the routing group. Because I think right now, if we were to sending over to the routing group, I think the recommendation potentially could be that we don't adopt the work because the draft isn't in a state where it's ready to be taken on. And so I think what you're hearing from us and from the comments at the other mic is that there's some work to be done to get the draft into a form where I think presumably you want the working group to take it on and adopt it as a charter item.
I'll do it.
Yeah.
As I said earlier, yesterday, like that will be, the fine tuning and this what all things has to be filled will definitely make it a more, granular level changes it's required to do that. That is what, that's what I got the message. I'll do it.
Okay.
So I know the more on the explanation and the test. Yeah.
Yes, Marius. So I'm just trying to echo Sarah here. It's not just fine tuning. It's like a spring cleaning. It needs a lot of changes, not just fine tuning. It has to be clear to you that the draft at this point is not in a stage to be adopted. It's unclear. It's unclear to people that are very familiar with EVPN. It's unclear to also everyone else. So it needs a lot of changes, not just fine tuning. That has to be clear.
Okay.
And because you keep repeating fine tuning, it's not fine tuning. That's what we're trying to say here. So I'm trying to be as straightforward as possible.
Yeah, fine.
I'm sorry if I'm rude, but I'm just
I want to know, like you said, it has to be clean. Quote me an example, because then it will be helpful for me, which is a viewpoint, because you state, okay, it has to be clean, it has to be done. That's the word. I accept the feedback.
That was one of the examples. It sounds like the diagram is not clear at all. Like it's not just fine tuning. It's not clear. Nobody understands what you're trying to write there. That's what I'm saying. So what you do with that feedback, that's your job as an author. Right?
Exactly. That's what.
And then,
the diagram,
your co-authors or even the working group is trying to give you solutions to that, and you keep saying fine tuning.
It's that is Marius. It's like fine tuning is where cleaning up all this. That's a term I used it.
Okay.
Don't misquote me. I mean, I respect your feedback, but the thing is, fine tuning means all the things has to be corrected. That is what the English is about, which I understand it. I respect your feedback. Definitely, it will be done. That's a commitment. Okay. I've told it. So, right. And if you can, you pointed me. I have noted that this is the things has to be done. I respect that it will be taken care, because each feedback I've taken very seriously. I've gone back to that and I've done it. So I will go through that in a different, because the test, what the EVPN testers which I sat with, and the parameters which I have given, so they were able to understand it. But the feedback which I got from you guys is different. So definitely that will be taken care.
Okay.
That is, I've clearly told.
Marius, it's his first time as an author. I think it's sometimes really hard to come into IETF and do this for the first time. I remember my first contribution, and it was at a different standards organization. It was a mess. And given the amount of, and I'm not saying this is a mess, I'm saying for myself, I remember it was a mess. And it took somebody really sort of saying, very kindly, wake up, here's how it's done. So could I ask, in the spirit of him being new and alleviating some of the pushback that we're getting on the feedback here, I've agreed to, and I'm wondering if you would, I think you're a fantastic writer and you've gone through the process really well. Could you take a look at the diagram, the first diagram in the document, and provide surgical feedback around that? Here's what doesn't make sense to me, here's what does, because I think he's really struggling with what I'm hearing is, I'm not entirely sure where. Give me some examples of what you're talking about. So if you take the first diagram, I'll take the first use case, and I think between the two of those, and we can even talk before we send it over if you want.
Yeah,
maybe that would really help him.
I can come up with a solution to what I'm trying to correct. Of course, I don't have the EVPN background that maybe is very critical, but I can also ask for help. We have people that are experts in EVPN, and the thing is, I think, as you were saying, even for people that know the stuff, it doesn't make sense.
Right.
So
that's why I'm hoping with that first set of feedback from us too, maybe that light bulb will come on and he's like, oh, sure. I see what you're saying. Yeah, I was making these assumptions. I wasn't writing it down. Now I need to go through, and he could run off with the rest of the draft. That's what I'm hoping.
And sure, that's a constructive way. I mean, then it will be easy because he will be thinking something in the mind. So I'm assuming, okay, this is what he assumes it. So because I was thinking in the mind where the EVPN actual scenario which I'm testing. So I was thinking, assuming that maybe that is a delta between us. If you can come up, you don't need to go deep into the EVPN, but this is a delta which is there in the, transforming the idea into that. If that will be a great thing if you can, that is what I am expecting it.
One more thing, it seems like even from the first time I reviewed the document, I told you pretty simple things. It wasn't very technical. It was mostly about editing, and there was a lot of pushback. So I think if you can try to, I don't know, dig deeper into the feedback and then consider it some more, and then make sure that it actually got covered, because you were saying this got covered, and then okay.
See, this is give and take. I mean, if you are okay, if something is missing, so this is that is action item on us. We are doing that. So that is the reason. Yeah, as a feedback, I mean, I'm giving that. Okay, this was the action item on us, so we have covered that. Oh, so that's why we are.
Sudin, I'm sorry. I'm going to interrupt there. So I want to be very clear. Giving technical feedback and somebody coming in and saying, you're wrong here, let me show you where you're right, I think that's very valid. But overarchingly, I think from 3 different people now, you've heard that the draft isn't clear and it's not reading. So it is not on us to do this. I'm asking Marius to help because I see you're struggling and I see you're not super receptive to the feedback. But I want to be very clear. At the end of the day, if the draft isn't readable, the working group is not going to adopt it.
Yeah, we will do it. Sarah, as a promise, we'll do it. I just request and help. He was telling, okay, this is, that's a missing part. If he can, one thing he pointed out is the diagram. That's why I committed. Yes, we will.
Right, but again, your examples keep focusing on specific examples, but I think you're missing the overarching point that you have a readability problem.
That already, as he pointed at the start itself, that's why I said I'll go through it, and I have to do all the editing works, and I have to really, focus on that. That I've already told.
Okay. So let's do as much of this as possible, the exchanges. Well, I was going to say, if people want to type stuff up this week and get that on the list, that's great. But it would be really good if we can make use of the face-to-face time and availability here as well, to be sure that what we're writing down gets communicated.
Yeah, sure.
And it's understood on both sides. I think that's the kind of thing that will really help this week. Sudin, I think that now if you give us a sort of a summary of some of the other benchmarks that you plan to measure, I think that would be a good use of the rest of the time with your presentation slot here today. And we'll accept that there's lots of feedback coming. By the way, if we adopt this, then you and your co-author become agents of the working group. And what that means is that you're representing the working group's opinions in the draft at that point. So you've got to be very receptive and efficient in providing the changes that address the comments, because the comments are a gift.
Yep, we'll add that. So some more. I think it's how many minutes left?
We'll finish up with what you got, and then we'll move on.
So it's this is a type 5 route which is added in that the latest comments which we received, because they want that, because this is not part of the RFC. This is in a separate draft which came. So this is where we are testing how what is the scale of the type 5 in a particular DUT it can support it. So this is one of the new ask which was in the previous IETF. So this we added, like you scale to in DUT to the X number, and whether it can able to sustain that. So that is the parameter which we added as an extra into that.
So type 5 is essentially IPv4 route with no associated MAC. Type 2 is MAC plus IP. They're both, the IP routes have to be stored regardless of it's type 5 or type 2. So maybe, I don't know what you're looking for here exactly with type 5 as opposed to a generic type 2.
No, type 5 is where, you don't normally it won't be, advertised as a type 2 because MAC plus IP, because this is not part of the EVPN.
No, my point is a type 5 or a type 2 contains an IPv4 prefix.
Correct. Yes.
Okay.
Yes.
You're testing to see how many of these prefixes I can store on a DUT.
That's correct.
So in many ways, why is type 5 different than type 2, is different than IPv4, is different than VPNv4? Like what essentially are you going for here? As a provider, I would be like, well, this is good, but what about my type 2s? And what are you trying to tell me? How it stores the IP prefixes when it comes from an EVPN address family versus a 2547 address family versus an IPv4 address? Or what are we? This is not about EVPN as much as it's about capturing updates with IP prefixes from the AFI-SAFI of EVPN and storing them. So
this is a capacity metric. Is that
right? That's
that
right.
right?
So I'm trying to understand what is it exactly?
This is it's a capacity, like normally the MAC plus IP will be if that particular the IRB is a part of that routing instance, then only it will be advertised as a type 2.
No, I understand that part of it, but I guess what I'm trying to say is that regardless of how you're using the route in this capacity with IRB or MAC plus IP, you're testing how many routes you can store, not the IRB, not the functionality of EVPN.
This is not the functionality, because this is the scale actually.
I understand that, but why is the scale specific to this one type 5 of an IPv4? Why is it not? Why do I need this specific test? Why can't I just test any kind of update that has an IPv4 prefix like a type 2 or a type 5?
Mm-hmm.
So I think his point is you could have met the requirement or the feedback that folks gave you last IETF in a more generic way, because I think right now, frankly, it feels like you shoehorned it in to say, check, I addressed the feedback, but I'm not entirely sure it does your document the service that you expect it to.
Actually, the last idea of what they said is like they want to measure the scale of type 5 routes. What is the DUT can sustain to that the type 5 it can. So that was the feedback they were looking at it. So
right, I understand that, but then again, I can sit here and repeat what Jimmy just said, or I think you should frankly consider what Jimmy is saying.
Yes.
Okay.
So this is a high availability test. So it is, when the failover, so the ideal case is, it's a zero packet loss, but in high availability, we expect none of the routes should not be withdrawn. There should not be any change in the DF elections or the type 2 routes or the type 4 routes and the type 1. So this is where the high availability test is. And this is a scale test. So we scale it to n EVPN instances. So, and we measure this, the max, which is learned on a Mac, as well as the EVPN scaling. So how long it will take, take to learn the Mac, and this how long it can sustain to that particular scale. So that is one parameter we are testing it.
Jimmy Target. So one thing about this, back in the day when we were testing VERFs, there was a limit to the number of contexts that could be configured, regardless of what you put in them. And then, of course, is the total amount of routing state.
Correct.
And then total amount of routing state divided over n. So it might be interesting to find out just how many EVIs a certain box can be configured
Correct.
with.
Correct.
Regardless of that.
Correct. So that will give you the exact picture, okay, when you test the different boxes. So
Just saying that we found when we were working with our vendors 10, 15 years ago that context by itself costs money.
So that context costs money. I mean, what is a context, and each context, what is the capacity? Because that is where, provider, that is where the money comes into. So this is the convergence, because the BGP updates which is going on. And this is, the convergence wherein we scale it to the N, EVPN as well as the MAC. So we measure, the flood, because how fast, because the main benefit, the EVPN, which is said, the flood towards the core is, reduced, minimized, unlike in data plane learning of VPLS. So we measure to, scale to N EVPN instances and to the MAC. So how fast it is in a bidirectional traffic, how fast, it learns and starts forwarding in the, forwarding in, bidirectional traffic, and how quick the flood is prevented. So that is where we measure the convergence. And the SOAP.
Wait, I'm sorry, go back.
Yeah.
So what you just said doesn't match your slide
Oh, sorry.
at all.
Yeah.
I mean, I'm not entirely sure I can even read that last sentence, to be honest. It doesn't quite flow for me. So is what you're saying you measured, or is what you've written what you think you've measured?
Measure the time period of the flood. This is the flood traffic, like, it is the DUT has to advertise this to the remote, and the flood should be reduced. The flood we are measuring in the DUT. So it is the flood, the measuring the flood traffic. So it should not be sent to all others. It will only send to the remote routers.
Okay.
So that is what we are meaning it. So the flood has to be, that is the important part in the in this particular test. The flood has to be reduced. How fast it has to learn this and programs the the MAC, and it has to send unicast, the bidirection it has to establish, and avoid the flood. So that is a flood we are measuring. The flood, how fast it is learning it. So to reducing the flood time.
So let's wrap this up,
Okay.
Sudhin. I think you've got tons of feedback here today. Just show us your last couple of slides quickly, and then let's move on.
Okay, the SOAK, it is then a normal, which is running, for 24 hours. It is with a scale setup, and it is running for 24 hours, and it should not have any crashes or any memory leaks. So
Okay.
that's the expectation of the SOAK.
I'll take it to the next. It's fine.
Yeah. Okay.
That's it.
Good. Thank you very much, and thanks for being willing to accept lots of comments today.
Thank you.
I think that you've gotten the feedback that that you really needed now to make this a better job.
Yep, we'll definitely work into it. Thanks.
Thank you. Okay, next topic. Next is Taki. And she's going to talk to us about considerations for benchmarking in service function chain. Hang on. All right, there you go.
Hello. Yeah.
Yep, it's working.
Hello. My name is Taki Kim from Korea Telecom. It is nice to meet you. And last time in Seoul, I wrote benchmarking test methodology for SFC performance. But as you know, SFC standardization is not finished, but we KT have to preparing for 5G Pyeongchang. So we are trying to have service E2E network slicings and enterprise services using SFC. So we do not have enough time to wait using NSH things. So before to benchmarking performance, we have to find out the SFC reliability is okay or not. So that's why I started this test. This is motivation. As you know, SFC is effective when the service requirements and the composition of the services is keep changing. But at the first time we set up the paths, when the switches are also initial status, there is no rules, there is no traffic. It was easy. But when you're trying to change the paths and add many rules to the switches, you know, for the many multi-tenant services, and in the circumstances that many services on the network, it's going to be hard. And then some switches make some more time to the other switches. So, okay, yeah. So as a perspective of operator, we think reliability of SFC is SFC operations must be done at the right time and at the right path. But before start this session, I discussed with the SFC reliability meaning with R, and then he give me comments that I think reliability of SFC terms is not a fit this topic. It's like more like the accuracy of SFC is more fit this term. So I accepted the feedback, and then I will revise this reliability of SFC to accuracy of SFC, because when we try to set up the rules to the switches, and then they activate what we propose. Yeah.
So it's just to clarify briefly, it's the speed and accuracy and reliability of SFC establishment. So kind of the first row of the matrix. Those are the kinds of things that you can measure in the SFC creation phase. And then when you have SFC deletion, that's actually the bottom row of the matrix. So then you have, when you're deleting an SFC, do you delete the right one? That's accuracy. How fast can you delete it? That's the speed. So you actually for all of these categories, creation, deletion, and modification, there's the potential to evaluate the speed, the accuracy, reliability, and also the scalability.
Yes.
So that's the fourth column that I didn't display this morning.
Yeah.
But when we look at this, let's imagine that the benchmarks that you're going to create will occupy some cells in this matrix.
Yeah. And then I have a question that if I want to change the path, some rules going to be modified, some rules going to be deactivate, some rules going to be adding. So in that case, the parameter are going to be checked multiple columns, right?
That's right.
Okay.
That's exactly right.
Yeah. Thank you. Yeah. So, scope. As I mentioned before, we have to launch the enterprise services and E2E network slicing in 5G, even though seems like a POC. But we do not have enough time, as I mentioned. So, at this draft, at this time, we do not use NSH. So, this draft does not consider NSH. And at the 5G network slicing and end-to-end network slicing, there is multiple domain, such as access domain, transport, and core, or edge premises, edges, and core. So at that time, we developed service actually, at this topology, there is just SDN controller, but we expecting SDN orchestrator. Then top of there is E2E orchestrator, and then at that time, some domain controllers are ruling every domains, and then especially in Korea, the small regions. So this is not that makes sense because we do not have that much delay or that much delay for the like a propagation, but I expect it's going to be standardizations, and so I think it is kind of broad regions such as like America or China things. So at this point, I mentioned the scope is multi-domain network, and I want to try to test multiple regions. So if someone have interested, and then I want to some collaboration with you guys. Anyway, yeah, I will started the other test. Yeah, so there is actually this is the whole items of this draft. Very simple. There are only 5 parameters at this time. So this is configuration parameters for benchmarking the SFC accuracy. So the first is a type of switches. There are a lot of hard working on get rid of virtualization and the physical, but still there exists. So the types of switches, which is virtual or physical switches, going to be affect to the accuracy of SFC. And the second one is the number of switches in the target SFC domains. And the third is the uses of the flow table of the target switches, which is like TCAM usages or flow table entries. It's going to be affect from when the SDN controller going to set up the rules to the SDN switches. The status of SDN switches is going to be affect the accuracy of the SFC. And the fourth is the physical distance between control switches. But this is what I mentioned before. In Korea, it's not that kind of very effective in Korea, small regions. But the last one is the traffic loads on the target switches. It is same like the status of switches. And then we are testing, the first thing is a rule activation time, because when I wrote these draft, SFC reliability means SFC operations must be done at the right time and at the right path, but some switches doesn't listen to my rule. So the rule activation time was the important things that we have to test. So the rule activation time at the 3x3 matrix, we thought it is activation and the accuracy. That column going to be the rule activation time. Is that right?
Well, the speed would be the time.
Yeah, because of the time.
And if it fails, like you had some occurrences, as you just said, then that would be the sort of the accuracy. You actually get the rule installed that you wanted. So it would be like a rule failure ratio, sort of like loss ratio or something.
Yeah, thank you. So the rule activation time we checked is the time interval from the new flow rule setup request to the time when packet starts to flow following the new method rule. So this is the end of my presentation, and a lot of comments are welcome. Yeah, thank you.
Good, thanks very much, KT. Any comments from folks here? Does anyone have SFC expertise? I think you need some awareness of that and some background in it in order to be able to comment here.
So can you remind me, I did not read the current version of the draft. I saw there was a bunch of things that changed, and I meant to go pull to see what had changed, and I ran out of time. But can you remind me, do you have because your slides reference physical switches as well as virtual switches, when you start to measure things like TCAM usage, are you putting guidelines around what you expect a virtual SDN switch to be residing on, because if it's running on bare metal servers, you're not going to have TCAM, for example.
But this time we tested on the white box switches. It's not with OFDPA. Yeah, but we do not especially start it to TCAM sizes right yet. But we just expect that maybe the TCAM size, as we know, TCAM were going to be affected, but we did not start it. But
So are you expecting TCAM utilization to be a measurement we're going to do on physical switches more so than the virtual?
no, I don't think so.
Okay.
All right, well, we'll find out as this proceeds.
Okay.
Yes.
Yeah, I think that's
Yes,
the move.
yes.
Warren.
So, Warren Kumari,
Warren.
quick question. Has this draft been discussed in SFC at all? In the
No.
SFC working group? Okay.
No, but I'm trying to discuss this going to just right after this session is going to SFC working group because I'm not expert there. Yeah, so I need your opinion.
Yeah, well, obviously, if we were to take this up, we'd have a good cross review with that one.
Is there any other? No.
Well, that's very good. Thanks so much for coming again and presenting your work, Kate. Very interesting. I think that, as you mentioned, the network service header, which you weren't able to incorporate in your own work.
Yeah.
If we have others who do have some expertise in that area, maybe have run some tests with MXH, then we can incorporate it either in this draft or as a part 2 version, something like that. So, so that would be good.
Okay. Thank you.
Thank you. So, according to the agenda, now we're going to do the rechartering discussion, and then our current work proposals look like this. We've got these different work areas proposed, and we kind of discussed the status of them in these dimensions. That whether we have a kind of a written proposal, is it in the scope of the charter, and that's just sort of my guess at that. Whether we've got drafts available, whether we've seen significant support at meetings, significant support on the list, and any notes on dependencies. So, we had a draft which was on performance monitoring benchmarking. It was actually focused on IETF99-BMWG-20170717-0930 recommendation for Ethernet OA and M. So we liaisoned with IETF Study Group 15, and we got a response back from them. They own the protocol, and they said this isn't worthwhile benchmarking. So I've summarized that as don't. I think that's valid feedback, and so we've sort of dropped this work from the proposals. Now we just discussed EVPN and PBB EVPN, and we believe we're on the way to adopting this draft. So I've made that one green, and you can see the kind of the result here that we've got significant support for meetings on the list. I will next time mention that we're still looking for additional clarity here in this document before adopting it. We had a proposal on virtual benchmarking as a service, which seems to be dead now. It was more like a research project. I see the look on your face. Yes, it was really sort of research oriented, and we kept challenging them to make it more about engineering and less about research, and I think the answer is the empty microphone. So we're not. I think that's pretty much dead. But we've got a proposal from our two friends at VMware, Samuel and Jacob, which had good awareness and many comments at IETF 98, but no review on the list since. So I'd like to sort of have folks take a look at that. Here's Takey's proposal on SFC reliability, accuracy, and performance in the setting up of these things. We've seen a revised draft there, and we'll update this depending upon what happens on the list. But I think you've got some good comments again here today, and some good interactions. And then let's see. Oh yeah, this is the China Mobile proposed a draft which we discussed in Chicago and actually several times previously. The issue that's been raised with their method is that they've got measurement devices sharing resources with the virtual switches that they're benchmarking. And we keep raising this problem, and we haven't gotten a good answer yet. So, and it's kind of overtaken by events. The contribution from the OPNFV, the switch project, basically said, let's take the measurement systems out of the picture and get them outside the sort of physical interfaces that connect. And actually, for network function virtualization in the telecom environment, that actually looks a lot like what our deployments were. So it's a good way to go. We'll just leave it at that. So we're not really considering this at the moment for update or for taking it up. But we do have three things here: EVPN, virtualized platforms, and SFC, which are clearly still in the run. So that's as a summary for the drafts that have been proposed. So now we'll begin our rechartering discussion. First, we've got to finish the existing work, and if we do that, we should do that before we get our charter going. But if we don't, we'll simply add it to the charter and claim it done when it's done. Let's hope we don't have to do that. But that's a thing. So I've just mentioned the work on SFC reliability. See, I didn't update my draft after we talked either. Thank you. So we'll revise that. But I've mentioned all three of these, and so now I'd like to open the microphone for any additional proposals or ideas that folks are thinking about that they might like to write a draft and bring it in time for the Seoul meeting. And Marius has responded to the challenge.
Yeah, Marius, I had a short discussion yesterday with Al about something that we are interested in, and that was, Wi-Fi benchmarking, and there's like benchmarking for VLANs. And I was looking to see if there are any other people that are interested, to see if we can start going discussion on writing a draft. And also, Al sent me the draft Alexander, which was a proposal that at some point was in BMWG, and for some reason it didn't get very far. Like it only had 2 iterations. Yeah. And it's a very good start, actually. The draft is well written, and I kind of I'm in agreement with everything that was written there. So it looks like a good start.
Tom Alexander, I forget the name of his company, but I think it's closed. He was working with 802.11 in their testing group. He saw some gaps in the work they were doing. We actually exchanged a liaison with 802.11T for testing at the time, and they said, sure, go ahead and do this. And I was the only person who reviewed the draft, with the possible exception of Scott Bradner, who actually became a co-author because of Tom's acknowledgement of his contributions. But Tom did an excellent job finding out how our working group works, understanding the organization of documents here, terminology, methodology, wrote excellent procedures, and it fell flat. No one besides me read it. So we didn't take it up.
So I was going to say, it's been a while since I worked enterprise Wi-Fi, and I used to do the Wi-Fi Alliance, and I'm wanting to see, hey, let's check with them to see if they're doing anything already down this path. I don't think so, which means we're clear. But separately, there's a whole school of folks who do the protocol stuff here for Wi-Fi. And so we'd have a couple, like I already have a couple of contacts we can solicit to see, hey, if we were to do this kind of stuff, can you guys help? Because I don't do enterprise Wi-Fi anymore. Otherwise, I would take the stuff home and we could do the benchmarking there too. But I'm certainly happy to at least look into a draft with you, and then we can connect with a couple of folks who I just checked they are here this week to see, hey, what do you think? How does this resonate for you? Because if we were to take it on, Marius, and then have to go out and do the review, we'd need folks with...
Sure, yeah, with expertise.
Exactly. Does that
Yeah,
make
sure.
sense?
Like I'm happy to contribute in any way I can because I want to see an RFC written on this subject. So
Me too. I think
Yeah.
just the whole debate right now about hotel Wi-Fi and the fact that Macs cause
Yeah.
issues upstairs,
yeah,
and
yeah.
Apple maybe would be a really good thing
Yeah.
for the industry.
Benchmarking is very good in this.
Yes.
In
One
this
of the,
sense.
I checked back to the old meeting notes, and which I'll also note that Tom Alexander wrote because he was an
Yeah.
absolute champion note taker.
Oh, really?
Yeah. Oh, yeah. I mean, we were like gold for all the meetings that Tom came to. So Tom raised this point in trying to get people to read his graph. He said back at IETF 71, that hospitals were beginning to take up Wi-Fi for the communications between their systems, and that if the Wi-Fi didn't work properly, lives might be at stake.
Yeah, it can literally save lives.
And so even with that call to arms, Al was the only guy who read the draft.
Well,
So,
I think that's because we don't have Wi-Fi expertise in this room. But I think getting those folks, these whole folks who do all the AAA we do on wireline, they do all the AAA on the wireless side of the house. They're
Yeah,
here. So I think we need to get the cross-pollination because I really firmly believe benchmarking for Wi-Fi is such a good idea. And we shouldn't, there's other ways to slice the cat without having everybody in BMWG be in BMWG just to get the reviews. I think there's a path forward. We just need to talk to them to see if they're willing to participate.
I'm
have
definitely
people
more
join us for that.
BMWG than
Yeah.
Wi-Fi expert, but I started being very interested in it after starting some tests, and I read a couple of academic papers, but it's not the same thing. A standard is a standard after all, and there's no benchmarking standard that I know of. So
So this is
yeah.
a great thing to chase down, and I will volunteer because I'm sure Tom's email address has changed. I will volunteer to get in touch with him on LinkedIn.
Yeah, maybe
I think I'm
he's
connected.
interested in continuing. I'm pretty sure I'm not gonna be. I'm gonna be remote, but I'm really willing to start work on a draft if we have some traction, like in writing. I mean.
Yeah, you've been perfect remote. It's just like having you in person. No worries.
Okay, thank you.
Yeah. So let's ask for additional volunteers. Anyone else who wants to work on wireless LAN benchmarking? And we'll share the current Alexander drafts with you so you can get up to speed quickly on what's been proposed.
Well,
Even
maybe
if it's
on the
just-
list we'll
Yeah.
discover some.
It's
So
just
we'll
interest,
take.
right? We don't know where it's going yet. If you read and it goes down a path where you don't care or it's not your thing, you can always withdraw. It's not a big deal. But getting folks to contribute ideas, even just as a user who pays for a hotel room with crappy Wi-Fi, you care. So give it a read.
Okay, thank you. That's my proposal.
Very good. Thank you, Mario.
Awesome.
Very good. So, yeah, there's actually several things that have been in my mind that we tried to take up and lost steam on. And one came up in the context of vSwitch benchmarking that we just got approved through the IESG. And that is the energy consumption with regard to networking devices. Actually, it came up in the data center benchmarking graphs, not the vSwitch stuff. So we had a draft on that as well. Again, that was the kind of thing that didn't garner enough interest in the working group, and we weren't certain that we had sufficient expertise or traction with the industry to take that up. But if anyone's interested in that topic in particular, I can certainly find and share with you the previous work on that. We'll see if we can make that go. But we won't do that unless somebody really wants to champion it. And let's see. Oh yeah. So connected with the talk I'm about to give, which is on the OPNFV vSwitch characterizations that we've done, actual measured results. There's a couple of ways in which we could update RFC 2544. And I'll get to that in a few minutes, but they have a back-to-back frame test, which I think needs a correction factor. So that's a spoiler alert. And obviously we need to do something with latency the latency measurement in RFC 2544 is based on a single packet. Of course, the manufacturers do more than that, but we should have a standard that captures what we really think is necessary. So I'm going to tell that story. So in terms of time, between now and the next meeting, I'd like to discuss new work items intensely on the list. Hear the proposals, see the drafts prepared and presented to the group. If we had to have an interim meeting, we could certainly arrange that. But the target timescale, I think, is that we would have proposed text for the next charter by IETF 100, which is in November this year in Singapore, and then have a face-to-face discussion about that to really sort of finalize what we're going to do and clean it up, and then in the next meeting time frame, then go forward with that text and attempt to get approval. But it looks like Warren.
Yeah, quick question. Does this actually new charter text, or is this just new milestones?
Well,
because one of them is a lot easier than the other.
You're absolutely right. So, in the end of the day, Warren, it sort of comes up to the way that you'd prefer to see charters written. The feedback we had in the sort of the earliest 15 years of benchmarking methodology was that we had this general charter, and we decided what fit within that charter and what didn't. But the feedback I got when basically Dan Romascanu gave us feedback as the ops management AD, that he said it improved our visibility to have very specific chartered work as like bullet items in the charter. And that means that every couple of years we have to recharter because we finished all those bullet items. It increases our visibility to do that and nails down some of the things that we're doing. But we've always had proposals come in like the IPv6 transition technologies, where we went to the RAD and said, can we do this under our general charter? And back then Joel said yes. So maybe our charter exercise, and this is something we can discuss this week. I didn't get a chance to get to do this before Monday morning. But if your preference is to go back to the general charter, under which we evaluate as a leadership team together what work fits and what work doesn't, and not worry about the specific bullet items, then that's a lot shorter exercise. And so let's think about that as well. All right, very good.
But be consistent, because looking at the charter, I realized, holy crap, you're right. There are like 3/4 of our charter are just paragraphs on the work that we've done.
Yeah.
And some of it's been done for some time. And then with the way the tool is set up now with milestones underneath, so anybody wants to understand under general what are they doing, he'd see it anyways.
Yeah, that's always been true, actually. The charter and the milestones have always been on one page. Yeah.
All right.
So I'm happy to go back to the way we used to do things, because I thought that was very efficient. Yeah. But at the same time, we should have a good idea of what the milestones are going to be.
Yeah, sure.
And so we need the same discussion. It's just that we're not making ourselves crazy writing text.
Yes.
Love it. All right, that's the most awesome feedback I could have imagined for today. Thank you, Ron. Makes our jobs all around the world. Yeah, that's right. So if you want, we can. Well, we won't have the milestones though. So let's go with this as we go. Very good. Any additional proposals? Okay. So I've got about a half hour to do this other talk. Let me quickly do that. So here we go.
We've never had such pretty slides before on BMWG.
And not likely to.
You in Beijing?
Yeah, this is, well, this was the template that they gave us to jam all our slides in, and for the summit. And all right, so this goes like this. Yes, there we go. All right, and this thing is perfectly in my way. Awesome. All right, everybody hear me?
Yeah.
Okay, great. So, so this is a talk about data plane performance capacity benchmarking in the vSwitch performance project at OPNFV. My co-authors are Trevor Cooper, who's the project team leader for this benchmarking vSwitch project, and Sridhar Rao from Spirit Communications, who arranged and conducted a lot of the testing we're looking at here during our PugFest and in times after, using our dedicated Intel supplied testing pod and so forth. And really all the folks on the VSPerf project who contributed and committed reviews and so forth, those are all folks we thank a lot. So here's the agenda. There's some background here on data plane performance measurement. We'll have the results and analysis, and then we'll probably skip over this last part, what VSPerf looks like in the future. So here's some background. The network network's going to have, let's see here, this thing is and if I point to it there, you can't see it. There we go. So the network currently has lots of dedicated devices, but we're replacing them with these servers and virtualizing our network. And so we have end-to-end performance that all the folks with these, these end devices need and expect to support their applications in the current environments. We've got the 3x3 matrix there, looking at, actually that's the 3x4 matrix, looking at the service performance indicators. We use it there as well in networking. We're going to have all these different SLAs, and important ones are packet loss, packet delay variation. When we look at the end-to-end performance, it's got to support these applications. And what that means is we have to allocate performance to specific devices across the network so that when their performance is concatenated, accumulated impairments and so forth, there we have, we'll have an accurate summing up of all these small contributions in order to support the end-to-end performance. So a vSwitch, which is a small component, inside a server inside the network, is only going to have a really small contribution to the end-to-end performance, and that's the challenge here. If we're only looking at one switch at a time, we're going to be very demanding of vSwitch performance. So when we do that, we have a bunch of different characterization scenarios that we take, and we've automated this vSwitch performance testing. Can you see better too if I back up a little bit? Okay, while the audience reshuffles. So we have these deployment scenarios, which I mentioned here, and you can see the vSwitch is represented in red. We've always got our test devices external to the vSwitches, so they go through physical ports in and out. And we've got what we call a physical to VM. That's the PVP coding here. When it's PHY to PHY, it's just physical port through the vSwitch to physical port. PVP is all the way up through a VM and back down through the vSwitch. And then we've got the PVVP through two VMs. And this is the bunny ears scenario. Yeah, I didn't name it, but I love the name. So this is what VSPerf does. It basically takes all these steps. It sets up various things, sets up the workload, the traffic generator, and so forth. Executes, collects the data, generates the test statistics. We've got the the full enchilada here in what we do. So VSPerf is one of the OPNFV projects in the testing working group. So it's located there in the circle, and you can see that we have other things for functional testing. That's way off at the left here. Func test, and yardstick is general performance for the platform. Storage performance, obviously, benchmarking for the server-specific stuff. Bottlenecks looks at analyzing tests in order to find bottlenecks. So here are all the data plane performance testing options, and this is kind of an eye chart. There's lots of detail here. What's marked in green is what we emphasized in this testing. So what you'll see is that we've got the capabilities, for example, under traffic generators. We've currently got an IXIA. We also have virtual commercial available to us, and we have 3 open source generators and receivers that we install on bare metal hosts, and again connect these through physical interfaces to the device under test. So that's key information for this. So we can also do OVS and OVS DBDK, and also the VPP sort of versions of vSwitch, and some other things. Okay. So here's the example test results and analysis, and we're going to do all 3 of these. We're going to compare OVS and VPP, different traffic generators, the impact of a noisy neighbor, and the back-to-back frame testing. I want to be sure to get to that today, because that's actually the thing that has the most implication on our work here. So let's look at, so the reason I made these slides available on the OPNFV site is that if they get converted to PDF in the IETF site, you won't be able to see these things build. And there's actually some animation here and fly-ins that will cover up other information. So you want to look at the original slides that build like this. So here we've got a comparison of both OVS and with DPDK and VPP using the RFC 2544 throughput testing, bidirectional. One key point, though, is that we're testing a single flow at this point, right? And in green, we've got the theoretical maximum based on the interfaces. I think these are all 10 gig interfaces. And for a single flow, what we see is that the blue OVS throughput at different packet sizes, it pretty much matches VPP. So, and that's consistent with previous results. So we expected to see that, and they're all about the same level with respect to the theoretical. In fact, where we're really getting some limitations here is only at the lowest packet sizes. So we're seeing packet header processing limits hit us mostly at the smallest packet size, smallest frame size, 64 bytes. So let's build the, okay. And that's the circle that emphasizes it. So let's click this one 3 times and see what happens. Oh yeah, okay. So now we're looking at average latency here, and what we notice is let's see, we've got these are really hard to read. So the two bars on the left are for minimum delay, OVS on the leftmost, and VPP next to that. And then we've got the same arrangement for the maximum delay, OVS and VPP, red and blue. Then we've got the same thing for the average delays. Green is OVS and brown is VPP. So the message that's being delivered here is that the delay is pretty minimal for the low packet sizes, but we do see a lot of variation there. Note that the maximum delays go way up from the minimum, and that really only happens at 64 byte frames. And then we get fairly consistent results across the maxima for the different frame sizes, but we see the large packet size averages going up here and getting closer to the max as we increase those sizes. So that's a That's a different form of characterization. And as I mentioned, right now, this isn't asked for in RFC 2544, this kind of latency examination. So this is one of the areas that I think we definitely need to expand. Sarah?
Did you draw anything from the fact that the OVS and the VPP numbers flip-flopped after you went from 128 bytes? I know they're super small, all said and done, but...
Yeah, I think that's the instability of the maximum. In other words, when you run these tests, you probably see some variation there, and that's going to be dependent on the stochastic coincidence of processes that affect the packets going through. I mean, we're talking about the delay of one packet. That's the max, right? And so I think that's what that's all about. So let's go on to the next thing here. Okay, so now we're going to increase the number of flows. And basically, we've got 4,096 flows. And here's where we expect to see some differences between the OVS and the DPDK performance. So we've got the same colors here and the same relationships. You've got the two mins, the two maxes, and the two averages. And what we see is that there's an inconsistency here for the 256 byte measurement. We saw the VPP average go way up while the OVS average stayed really low. And this is worth chasing down. This may be due to the sizes, specific sizes of the packets that were in use and some sort of processing time there.
How many times was the test run? I feel like I'm channeling Scott, sorry. How many times was the test run?
A lot of times. Actually, when we saw anything that looked crazy or inconsistent, we reran it. And so this is one of the runs, just to be consistent, but we saw the same thing happen over and over, yeah. Marius.
Marius, just to extend that comment, how long was the test run?
Long enough. I know I'm being a real jerk about this. but there were at least 60-second durations, I think, at each one of these steps. Yeah.
Thank you.
Oh, hi. This is Venkatesh. I'm from eBay. I'm pretty new to this group. One thing that comes out to my mind is, why are we not...
Yeah, get closer to the mic.
Why are we not measuring the 99th percentile, just having the min and average?
You're my best friend, because that's what I've been telling people to do around here for a long time. Okay, because it's just that right now the test equipment doesn't support that.
Okay, because that could address our peak on the 256 byte, whatever we are seeing that.
Yeah, and that's how we can get rid of this instability with the max too, when we look at these high percentiles.
Okay, thanks.
Sure. No, great question.
That's all my question.
Yeah, and thanks for joining the group, because I'm sure we're all going to have some old test equipment we want to sell on eBay.
You're very welcome.
Oh yeah, so there's one more circle, right? All the things Al said. All right, so now we're going to look at OVS and VPP for multi-stream 64 and 128 byte packets. What are we getting at here? VPP throughput can go up 70% higher than OVS. That's what we learned, and that was consistent with previous light reading European Advanced Test Center testing. But there's some inconsistencies here. The 4,000 flows had lower throughput versus 1 million flows. So that's what we're looking at here. We've got 1 million flows. There's some cases here. In fact, I should probably click it one more time, and we'll see that. Yeah. So OVS actually had better throughput for 1 million flows than for, it doesn't make sense. It doesn't make sense. But we saw this over and over again. So there must be something here that we don't fully understand. Of course, it's at the smallest packet sizes too. In other cases, well, actually, the case next to it is OVS was still higher there. So this is something that needs to be chased down. But this is the kind of thing that you can do with these So here's the possible reasons: the packet handling architectures, the actual construction of the packets in the test generators, and whether the test traffic is actually fixed size. These are something to look at. So cache missing. This is an internal measurement. I'm sorry, Sarah, go ahead.
No, sorry. So you said the possible reasons test traffic is fixed size, but if this is a 2544 test, then under 64, I assume that's 64 byte packets, right? There's no IMEX going on here, so.
No, I'm actually having some trouble remembering what we said, what we meant when we said that.
Okay.
I think it's maybe just the fixed duration of the test or something, and over time we would have seen the throughput vary, or maybe with a longer test we would have revealed these differences with the smaller number of flows. I don't know. I'll have to go back to my co-authors and find out why we said that. But we put these together. It's like a month and a half ago now.
Okay. And then I don't want to steal your thunder. I'm trying to be patient, but I thought since I'm up, I'll ask. Did you run any of these with an IMEX profile?
No.
You just didn't do it, or you rejected it for a good reason that you can tell me?
We rejected it because it's currently not a capability of VSPerf to do it.
Okay.
And we're still sort of arguing about how we're going to do that generically. So it's more of a development thing, because it turns out when you specify IMIX to the different generators, they all want it differently. Yeah, so that's a pain for us. We want to do it one way and then have all the generators adopt that, and we kind of put it on the back shelf. But it's not a generator limitation. It's more a VSPerf limitation. So well spotted. My hat's off to you. All right. So cache missing was supposed to, people thought that cache miss was supposed to account for the difference in performance between VPP and OVS. It requires further analysis, apparently, because we didn't actually see a difference when we looked at the cache miss results. So here's the lessons learned, all the stuff we said. In the simple performance test cases may not provide meaningful comparisons. We actually, got some different results from when compared to the EANTIC tests, and there's a reference to that there. And of course, they used a different architecture than we used. I skipped over what our architecture was, which you do when you're in a hurry. But I can certainly, actually in the updated version of the agenda, you'll be able to go to a wiki page that has all the documentation and actually written discussion of all these results. So I'll pass that along in the updated agenda. So the results are use case dependent. There's going to be impact of the deployment scenarios and so forth. Obviously, there could be realistic and more complex tests that may impact the results significantly. IMIXs, as we mentioned. The searching for throughput maximum may be a factor here, and that's the searching algorithms differ from system to system. The device under test always has multiple configuration dimensions. Hardware and software can limit the performance, and it may not be in obvious ways. And the metrics can be deceiving, without proper consideration to all the above. So now we're going to look at a comparison of the bare metal but software-based traffic generators. So they're comparable to the hardware reference for larger packet sizes in general, but the small packet sizes show inconsistent results between VPP and OPS and between the single and multi-stream scenarios. So for now in our project in VSPerf, the existing bare metal software traffic generators are unable to provide latency values. We seem to be able to get them from some things in some ways, but not all of the software ones. Sarah?
Was there any thought that the traffic generators themselves might be part of the problem?
Yeah, that's exactly what we're getting at here. Yeah. In fact, I think what we're going to end up with when we finally do a grand RFC 2544 update is many more specifications on the generators themselves. We really have to nail down what we mean when we are asking for a consistent, continuous bitrate traffic stream, which was specified enough in the early days, but now let's look at these results and you'll see what I mean. Okay, is there a thing here? Let's see. Oops, nope, I didn't want that. Okay, so now we're going to look at 4 types of traffic generators here. We've got the hardware generator that I mentioned before, and 3 bare metal generators. And what we notice this is for OVS throughput, and over here for VPP. And here's the comparison I want you to make. For the red bare metal generator B, we've actually got significant lower throughput here at 64 byte sizes, and even at 128 when looking at OVS. But VPP, now the red generator is doing as well as the hardware-based, and actually it's the C generator that has some reluctance to produce packets in a way that result in its, well, I mean, it's pretty close to its previous throughput with OVS, but it's greatly reduced now here. And of course, with the large packet sizes, it's not such a big deal to evaluate. But these are the important ones because this is where we're really seeing queuing, where we're really seeing packet header handling limitations, and so the characteristics of the generators here are going to be a factor. And I'll say, tipping some future slides, that when I looked at this, I said, okay, these are bare metal generators. They may not be producing packets in the constant bit rate stream as carefully as some of the others. So let's look at some of the additional testing, like the back-to-back testing, and see if we can actually discern that for some of these devices. Marius,
just to clarify, is that a 1 gigabps line rate? I'm trying to read the zeros, and
oh yeah, sorry,
it's maybe 1 or maybe 10.
I think these are all 25 million, but let's count it.
So that's a 10, right?
These are all 25 million frames per second. Maximum 25 million.
Okay.
All right. Yeah, that was one of my complaints about these things too. I can never count all the zeros. Yeah.
Yeah. Thank you.
So that's 25 million. So then we have something else here too, which comes up like this. So let's see. Now we're looking at the 4,000 flows. And we're looking at 2 of the hardware generator, 1 hardware generator and 2 software generators on bare metal. And now, for some reason, we're seeing really improved throughput for the software generators. The hardware generator is really suffering here for some reason on OVS. And yet, let's look, here they're all pretty much, everybody's happy. The only difference here is OVS with DPDK and VPP. So this is a really great cause of concern, especially at these lower packet sizes. So this is, again, why I went into looking at this, the back-to-back frame testing, and if we'd see different results. So on to the next 2. Okay. So, given that I'm running out of time, I'm going to skip a few things here. What do we got here? This is... this is these are tests with the traffic generator as a VM. It's mostly restricted to the lower packet sizes where you've got a difficult comparison here with theoretical. And this didn't achieve the same throughput levels as the others. So this VM-based thing, even though it's running separately in bare metal, it's not working as fast. So, come on. And this is a complicated thing, probably nobody can read. So I'll let you take a look at this in the other thing for latency. But this is the one that produces pretty good measurements of latency in the VM. It's just that you can't get the throughput levels that we would want. So here's the summary of the lessons learned. Inconsistent results seen across the different ones. Packet stream characteristics may affect it. Bursty traffic, actually more realistic. So we're going to look at the back-to-back tests. These are back-to-back frame tests to confirm the DUT sensitivity and the switching technology not equally sensitive to the packet streams as well. All right. I guess that's the same thing in pictures. All right, so we also did some noisy neighbor test. What happens if you've got a stressing VM and it's going to affect your performance, obviously. And the CPU configuration and the NUMA isolation, that's the the non-uniform memory access nodes where the CPUs are in a ring. That can protect you from the majority of noise, but the last level cache is the key to creating that noise, because you can't get segmentation or partitioning there. So so that's the general finding, and I don't think that's a big surprise. So here's some results, and what you see is that with the noise level at the maximum high level cache consumption, 100%, performance drops a lot in every place where these arrows are. So that's kind of expected. All right, so finally, we're going to look at the back-to-back frame testing analysis. So this is a section in RFC 2544. The goal of the test is to seek the maximum burst length sent with, the packets are sent with the minimum packet spacing on Ethernet. So they have a minimum Ethernet frame gap and a preamble. That's the only thing that separates them. They're transmitted through the DUT without loss. And so you're increasing the size of the burst, and if you see it without loss, then you go to a higher burst and so forth. So it's another form of searching. Okay. So we did this with the hardware traffic generator. We did it in the phi to phi configuration that I've reproduced up here, just with OVS with DPDK. And what we recognized is that we have tests running in what we call continuous integration, which is where we test our software every few days and make sure that it's still running, make sure that we haven't done something in the test code that causes the results to vary horribly. And so we're performing exactly the kind of test that Scott Bradner envisioned when he ran the original back-to-back tests and was unable to get consistent results in some circumstances. This is, I really wish we'd done this while Scott was still here, and I plan to have a kind of an offline discussion with him anyway. But I recognize that our CI testing basically makes a perfect place for us to evaluate these results. So in the particular pod that we tested in, Intel Pod 12, we have results every few days from February through May this year. And what I've plotted here is the time series of results ordered by the frame size. So you see all the 64-byte results, then all the 128s, 512s, and 1024s and 518s. So as time actually goes to the right here, and that was just the easy way to represent this. So here's the interesting thing that happens. You've basically got this model of the traffic generator sending traffic into a buffer, and that's handled by a header processor, and then the burst goes out to the receiver. Now, if the header processing is able to keep up with the traffic generation for packet sizes in various with various sizes, then that means basically that you don't create a buffer. And what you're actually seeing, if you go back to in your mind, go back to the throughput results that we showed for the higher packet sizes, we aren't seeing a throughput limitation in the PVP case at any of these packet sizes, 128, 512, 518. In fact, we're sort of seeing it a little bit here, and the test generator is reporting these incredibly large burst sizes that are accommodated in the buffer, quote, quote, of the test device. That can't be true. It can't, all these burst sizes correspond to 30 seconds of packets having been sent. So we know that that's actually a limitation of the test device. It stops sending after 30 seconds. But it took some sorting out to go through all this and figured that point. In fact, if I jump to the next slide, so back here in red, here's all the different frame sizes plotted over the same time scale. And what I've plotted there is the buffer time in seconds that you would assume comes from the length of the burst that's been sent. And look at this. They're all 30 seconds down to 512. 128 shows some variability, but they're on the order of 3-4 seconds. We know this isn't true either. This is really just having some trouble characterizing the throughput there. And it looks like the 128 packet rate was on the cusp of just sometimes being accommodated by the packet header processing and sometimes not. So that's why we see some inconsistency here. But we see really consistent results for 64-byte, and those were the cases where throughput was limited. It was always less than the maximum theoretical throughput at 64. While I've got this one up, we had an old pod that we used to run these tests on back in 2016, and there we see consistent results too. So changing the hardware, changing the networking, changing a lot of things, we still got consistent results for the back-to-back testing. So backing up. So here's the main point. We have this average burst length that we've accommodated was 27,700 frames. But like I said, there's header processing going on here all the time. So if what we're trying to do is measure the size of the buffer, then we have to account for how many frames have been pulled out of the buffer by the header processing operation when we've sent 26,700 frames. It turns out to be more than half of them. So when I correct for the throughput that we've measured, the corrected buffer size is actually 57,013 frames on average, or only 0.384 milliseconds. And that seems to make a lot more sense with the hardware we thought we had. Now the trouble is, and with similar results for the other Intel pod. So the trouble is none of these corrections are mentioned in the back-to-back frame discussion in RFC 2544. So this and the latency measurements, I think, are parts of that we should update soon, and that's why I'm proposing this work for our next charter. And I see some nodding. That's good. Yeah. So I will, of course, discuss this with Scott, our chairman emeritus, who's kind of retired from all this, but I still see that he's monitoring his emails. So he's still with us in spirit, and so I'll share this with him. So I mean, you guys can take a look at this. We're running out of time. But any comments, any other? I really appreciate the feedback I got today, and like I said, on the list you'll see a link to our wiki where we've tried to explain, especially this calculation of the correction factors in back-to-back testing that I went over very quickly. I show that for all the packet sizes and why the throughput is a critical factor there. Marius.
Yeah, thank you very much for the presentation, Al. It's nice to see some numbers
yeah.
every now and then in a presentation and pick on them a bit. And it looks like a very interesting work, and I would like to see it here developed. And are the slides available?
Yes.
I haven't checked the.
Yeah, so they're like I said, they're not on the IETF website because you won't be able to see the animations. And they'll be converted to PDF.
I would like to get a deeper look at the studies, if that's possible. So if there's any, I don't know, was there a paper behind this, like an academic paper?
Yeah, there's all the stuff is on the wiki. That's where we explained everything that we did. So the link to the wiki, I believe, is in the mail I sent last night, but I'll check that.
Yeah, I'll dig deeper.
Yeah,
thank you.
Yeah, okay, all right, and if not, I'll send it again. But. Everybody, thanks very much for a good meeting. Any final comments? Any other business?
This is Ganesh. Can you put the wiki link in the Etherpad also? Because I find the slides on the Etherpad, but the wiki I didn't find.
Okay.
Thanks.
Yeah, it may be on the. It'll definitely come out on the mailing list. So please subscribe to BMWG, okay. and if not, just give me your card and I'll get you these things quickly. Okay. All right.
Thank you.
Very good. Thanks, everybody. I really appreciate your good discussions today. We made a lot of progress here. Thank you.
Big banner across typing. These ones kind of suck. Look at the originals here.
Okay, that's easy enough. Just I didn't want to have to remake them all so that they
just put that way we have an archive.
Yeah, good
and
enough.
point to the real one as well.
Yeah.
if you add a slide, so that you upload it, it'll say go to BMWG.encrypted.net.
Yeah.
That's where they can pull the PowerPoint.
Yeah.
Then you get both of both.
Yeah, best of both worlds. Yeah, yeah, that's easy. That's easy enough to do. I was thinking I would try to do the build the animation thing. Yeah, you end up with 100 slides and nobody looks at it. I know a couple of Comcast guys, but I mean, I didn't want to impose on them. I guess maybe like somebody like Jason Livingood or Brzezowski, John Brzezowski, either of those guys. For some reason, I didn't see the email that said you need to review this.